As a truffle grower, it's useful to be able to evaluate the condition of your truffle orchard, to be able to verify that the species of truffle that you inoculated your trees with originally is still present today. In previous videos, we showed you how to sample roots from your truffle orchard and how to prep those roots. And in this video, I'm going to show you how to look at those prepped roots under the microscope, and we'll talk about some microscopic characteristics that are useful in verifying the presence of truffle species on those roots. The microscope that we're going to need to observe roots is called a stereomicroscope. They're also called dissecting microscopes. They are generally low magnification microscopes. This one has a magnification range between 8 and 56 times magnification, but anything roughly between 10 and 50x is suitable for looking at roots. These microscopes are equipped with a top light, and this is the method of illumination we'll be using when observing root tips. It's the best. Sometimes these microscopes also have a bottom light, but for root tips, I prefer just the top light. If this is the first time you're using your microscope, it's good to adjust the diopters here so that the eyepieces line up with your eye and it forms just one circle of vision through the microscope. And when you observe root tips for the first time, start out at a low magnification, the lowest magnification setting on your microscope, and then use the focus dial here on the bottom to bring your subject into focus. And eventually, as we're observing those root tips, you can rotate your zoom dial to increase the magnification and then re-bring your subject back into focus. So the tools that you're going to need for observing roots are, number one, a petri dish, and this will fill with water and then put our roots submerged in it. You'll need some forceps, and these are fine-tipped forceps. Now, I highly recommend that you keep the tip protector because these are precious, and once the tips bend, they're almost impossible to use. So I highly recommend that you take care of them. You'll also probably want some scissors, just for cutting any long pieces of roots that you might have. And these are optional, but I think it's really worth it. Use a dark background. I have a piece of black felt cut out here, and I set it down on my microscope stage, and then I use these little spacers to create a gap between my background and the roots that we're looking at through the microscope. And this is really useful because what it does is it separates the root tips that you're observing from your background. And so when you focus in on the root tips, the background is blurred out, it's out of focus. So I've just put some root tips in here, and what I transferred was a relatively small section of roots. And I'm not sure if you're going to be able to see this. I'll put a picture up if you can't see it that well, but this is a fairly small segment. And if you're doing this for the first time, start with only one segment at a time. It can get really busy in your petri dish pretty quickly. And so make sure your roots are completely submerged in water. And you turn on your top light. And you can use your forceps to kind of move your roots around. And you'll be moving the roots towards the center where you'll actually be able to observe it through the microscope. So we'll take a look here. So what we're looking for are ectomycorrhizal root tips. These are root tips that have been colonized by an ectomycorrhizal fungus. Truffles are ectomycorrhizal fungi. And what that means is that they form a mutual symbiotic relationship with their plant tree or host. And what they're doing is they're gathering water and nutrients from the soil and exchanging those for sugars from the tree. And they form these structures called Ectomycorrhizae, and it's the morphology of the Ectomycorrhizae that we're going to be examining. Okay, for non-colonized root tips, they generally have a pretty uniform shape. And what I mean by this is that the basal diameter of the root tip is roughly the same as the tip. So in this case, it does taper a little bit, but generally speaking, it's fairly close to uniform. And this is in stark contrast to ectomycorrhized root tips, which you'll see they're fairly ununiform. Now, they're also commonly translucent. So you can see the tip of this non-colonized root is fairly translucent. It's common for the younger tips to appear like that. Sometimes you'll be able to see at the higher magnification, this is 30 to 40x, the root hairs. And these are a little bit thicker, relatively speaking, for an emanating structure, and they're somewhat clear. Now, an emanating structure is any structure that's coming off of the root tip like this, and they can vary in shape and color and length, and you'll see a lot of examples of those pretty soon here. Now, the root tips themselves can vary in length, and they're pretty short sometimes, but they can also be a little bit longer, and this can be dependent on the actual tree species of the roots that you're looking at. So you'll notice with pine trees, they're generally quite large compared to other tree species like oak and hazelnuts. So for characteristics of Ectomycorrhizae formed by tuber species, we'll start with color. Generally, they're brownish to an ochre to an amber, and sometimes they're a little bit lighter at the tip. Now, the color can really vary based on the lighting of your microscope and what color the background might be and the quality of the microscope, but generally speaking, it's going to be a brownish. So for the shape, we don't have a better analogy, but they look like corn dogs. And sometimes we describe them as being somewhat bulbous, but yeah, they start out fairly thin at the base, and then they kind of taper out and form this bulbous-like shape. And what I want you to imagine too is that inside here, there's a tree root, and what the fungus has done is it's encased that tree root, it's enveloped it, and that's the structure of the Ectomycorrhiza. So this is an emanating hypha that's coming off of the root tip. We sometimes call these cystidia, and they'll vary in form. They're typically clear to yellowish. And this is a picture of tuber melanosporum. And so sometimes the emanating hypha, you'll see they branch off at right angles. And that's characteristic of T-mel. Other species don't typically do that. There are some others that do, but that helps you differentiate it from other species. This picture, I think, is a good example too of what a broken root tip might look like. So while you're examining samples, you might see something like this, where this appears to be kind of the base of an ectomycorrhizal root tip, and then it must have snapped off right here, and this is maybe some internal leftover root tissue. So this is something you might commonly see. So as you can see, there's some variation among tuber species. Looking at T-mel specifically, like I mentioned before, you can kind of see it in this picture. It's got some branching cystidia there. You can also see how the root tip is actually a little bit lighter in color compared to the body. Another thing I want to mention too is in between the little crevices here, this is just like leftover soil or debris that I couldn't actually wash off these root tips. And so that's something you'll commonly see. It can be a little bit reflective as well. But taking a look at the differences, like look at T. aestivum. It's got so much of this cystidia, and we kind of describe it as being woolly, but it prolifically produces cystidia. And these cystidia do not branch, but they're fairly long. Now, over at T. borkii here, you can kind of notice the cystidia are a little bit shorter, and they're also quite spiky looking, They go over the whole range of the root tip here. They're also a little bit lighter in color at the tip. But yeah, they're much shorter. For borkii, it can be that they can be a little bit longer, and we'll see some photos where they are. But that short, spiky cystidia is fairly typical. Another interesting thing about T. borkii is that it has this tendency to fork, and you'll see this repeated in a lot of examples, but it's not always present, but it does have this interesting tendency to fork. So here's some other photos of T-Mel, also called the Paragored black truffle, and we can see again here some branching in the cystidia, lighter tip. It's got that brownish color. On the right, this is a really good example of, the shape where it gets a lot thicker here at the root tip, and it's fairly narrow at kind of the base. But these are also fairly long roots where it's colonized just the tip here. And this looks a little bit more brown in color too, whereas some of those other pictures kind of looked a little bit more amber. And that color difference, as I mentioned, can be, just lighting, or sometimes it can also be ecological based on what soil or, other characteristics like that. Okay, in this picture of T-Mel, you can see the difference between some non-colonized roots here on the left and some colonized roots on the right that have that classic corn dog shape. They're brownish in color. And this one at the bottom here even has some clear cystidia that's coming off of it. That's characteristic of tuber species. Okay, here we have two pictures of T. aestivum, and you can see there's just so much cystidia on all of these mycorrhized root tips. And I think these two photos really showcase the difference between what a lighter background on the right will do to the color of the image and the appearance of everything compared to the darker background on the left. For tuber borki, the bianchetto truffle, we see more of this forking that we saw before, some more spiky clear cystidia. That tip of the root is a little bit lighter here. Look, you can see some cystidia over here that's quite a bit longer. T. bromali, the winter truffle, is known for having this short spiky cystidia that you can see here on the left. However, it's not uncommon for the cystidia to be absent, as you can see in the photo on the right. In this photo, we have T. caniculatum, the Appalachian truffle. So on these root tips, we have that classic corn dog shape that we're looking for. The color is brownish to amber, and looking at the cystidia here, it's clear to yellow. For Ectomycorrhizae outside of the genus tuber, there's a lot of variation that you might observe. And that's because there's thousands of different ectomycorrhizal fungi that are out there. And so what we're looking at are those three characteristics we've been talking about: shape, color, and then the form of the emanating structures. And so if one of those three features is not what we were talking about, it doesn't match what we were talking about before with tuber species, then it's unlikely that the Ectomycorrhizae you're observing is a part of the genus tuber. So for the shape, this varies widely. But if you look at the photo on the right, you can see these root tips kind of meander, which is uncharacteristic of tuber species. And the color is kind of like this white, almost cream looking color. And you do see some emanating hyphae. They're somewhat clear in color. You can barely see them here. And so only one of those features matched tuber species. And so it's unlikely that this Ectomycorrhizae is a part of the genus tuber. And this Ectomycorrhizae is actually Scleroderma. It's a genus of fungi that form puffballs, and they're quite common in truffle orchards. So here we have a few more photos of non-tuber Ectomycorrhizae. So starting in the top left, we have some clear cystidia here in that classic corn dog shape, but the color being, that light cream, I would suspect this is non-tuber Ectomycorrhizae. In the top right, this is actually a photo of Cenococcum geophyllum, which is a ubiquitous ectomycorrhizal fungi found in many forests throughout the world, and it's characteristic for having, that corn dog-like shape. It's very black in color, and it has really thick emanating hyphae coming off of it. In the bottom right, this is another photo of Scleroderma, and yeah, it's got the clear hyphae, but white reflective. And in the bottom left, this is, I think, a good example of Ectomycorrhizae that appears to look very similar to tuber species. So it's got the classic corn dog shape. Even some of the root tips are a little bit lighter in color, which is characteristic of tuber. And yeah, it's that brownish color that we're looking for. But look at this root tip here, and look at the emanating hyphae coming off of it. So these are pretty dark in color and they're highly branched. And that right angle branching is characteristic of T-Mel, but because the color is as dark as it is and they look fairly thick and they're so highly branched, I would suspect that this is non-tuber Ectomycorrhizae, and in fact it is. Here's a few more photos of non-tuber Ectomycorrhizae to show off a little bit more of the diversity that you might observe. Now, I think it's important to note that these morphological characteristics we've talked about so far are fairly general, and they don't allow us to absolutely distinguish between tuber Ectomycorrhizae and non-tuber Ectomycorrhizae. But what they do is they allow us to filter out a lot of these fairly obvious non-tuber Ectomycorrhizal species. So I think this is actually a really good example of a species of non-tuber Ectomycorrhizae that has overlapping features with tuber. So it's got that corn dog shape, it's brownish in color, and it's got clear cystidia. And so since it has these overlapping characteristics and we can't distinguish between tuber and non-tuber, what we have to do is we have to use DNA identification tools to verify with certainty that the colonized root tips that we're observing are in fact colonized by that species of tuber that we think they are, as opposed to some other non-tuber Ectomycorrhizal lookalike. So with that, thank you for watching, and for more information on truffle testing, please go to go.ncsu.edu/trufflelab for more.